All right, welcome back. In this next example, we have x minus 3y equals 3 and 3x minus 9y equals negative 18. And we're asked to solve this system of equations by graphing. So I'm going to start by rewriting both of these equations in slope-intercept form, beginning with x minus 3y equals 3, subtracting x from both sides. We have negative 3y equals 3 minus x. Divide both sides by negative 3. I'm just going to divide each term on the right-hand side by negative 3 and then simplify it down. On the left, we're left with y equals 3 over negative 3 gives us negative 1 plus x over 3. I'm just going to take one more step here and rewrite this as y equals negative 1 plus 1/3 x. This way it's really clear what the slope is and what the y-intercept is. Here the slope is 1/3, the vertical intercept is 0, negative 1. So I'm just going to go ahead and plot this here. There's 0, negative 1. And the slope is 1/3. So from this vertical intercept, I'm going to go up 1 unit, to the right 3, up 1 unit, to the right 3, and we can also go down 1 unit and left 3 to define the line. So connecting the dots, we have, let's see, as straight a line as possible. There we have the graph of this first equation. The second equation, we have 3x minus 9y equals negative 18. Subtract 3x from both sides. We have negative 9y equals negative 18 minus 3x. Divide both sides by negative 9. I'm going to go ahead and just divide each term by negative 9. So we have y equals negative 18 divided by negative 9 is a positive 2 plus negative 3x over negative 9, so we have x over 3 again. Just going to rewrite this y equals 2 plus 1/3 x. There's the equation of our second line. Graphing this, here's the vertical intercept. There's 0, 2, up 1, right 3, up 1, right 3, down 1, left 3, down 1, left 3. Connect the dots as carefully as possible. And there we have the graph of the second line. Now something to notice here, when solving a system of equations, we're looking for the intersection point. These two lines, not only do they not cross on the graph that we have drawn here, but if you look back at the equations themselves, the slopes are the same. These lines are parallel. Parallel lines will never cross. So this is an example of a system of equations where the two lines will never cross. So this system of equations has no solution. All right, it is a special case. It only occurs when the two lines are parallel. Now this next example, in example 5, we have another system of equations. This one, 2x plus y equals 3, and then 6x plus 3y equals 9. Again, solving both of them for y, we have 2x plus y equals 3. Subtract 2x. We have y equals 3 minus 2x. There it is, already in slope-intercept form. The vertical intercept is 0, 3, and the slope is negative 2. So negative 2 over 1, that means we go down 2 and right 1. So down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And we can also go up 2 and left 1. So up 2, left 1. All right, filling these in, writing in some of these points. This was 1, 1. This was 2, negative 1. This was 3, let's see, negative 3. And this one up here was negative 1, 5, it looks like. All right, connecting the dots with as straight a line as possible. There is the graph of the first line. The second line, we're going to do the same thing. Here we have 6x plus 3y equals 9. Subtract 6x, subtract 6x. We have 3y equals 9 minus 6x. Divide by 3. Divide each term on the right-hand side by 3. So we have y equals 9 divided by 3 is 3. Minus 6 divided by 3 is 2x. Now something that you notice here, these are the same lines. Y equals 3 minus 2x. This is the exact same line. So here, if we were going to graph it, it would be exactly the same line. It would graph right on top of this first one over here. So this system of equations actually defines only one line. Both equations graph as the same line. Now, as such, remember we're looking for the point at which the graphs intersect, or that they cross. They cross at absolutely every point on the line. So in this case, we say that there are infinitely many solutions.